Have you ever really stopped to think about what happens in that tiny sliver of time after you type a website into your browser and hit enter? I mean, it feels instant, right? But what's really going on is this incredibly complex, high-speed journey. In this explainer, we're going to pull back the curtain and follow that journey from start to finish. So yeah, what is going on in those milliseconds? We're going to trace a single web request all the way from your keyboard, out across the internet to a server, and all the way back. You're going to see all the secret handshakes and hidden express lanes that make the modern web actually work. It's this wild ride that happens in literally the blink of an eye. All right, here's our game plan. First up, we'll see how a simple URL gets translated into an IP address your computer can actually use. Then we'll look at the secure handshake that keeps your information safe. After that, we dive into the world of CDNs, content delivery networks, and see how they make everything so fast. And finally, we'll compare the big players out there so you can figure out which one might be right for you. Okay, first things first. We humans love names, like example.com. But computers, they speak in numbers. IP addresses. So the very first step in this whole process is translating that name into a number. And that's where the domain name system, or DNS, comes in. You can basically think of it as the entire internet's gigantic, super fast phone book. Now, you might think your request just goes straight to the source to get the answer, but it's actually more like a little scavenger hunt. It starts with a recursive resolver, which asks a root server, hey, where do I find all the .com stuff? The root server points it to the TLD server for .com. Then that server points it to the specific authoritative name server for example.com. It's only then that your browser finally gets the IP address it was looking for. It's this rapid-fire four-step dance that all happens in just a few milliseconds. It's wild. So here's a super simple way to think about it. The recursive resolver is kind of like a helpful librarian. You ask for a specific book, and while they don't have every book memorized, they know exactly how to navigate the library to find what you need. The authoritative name server, on the other hand, is the dictionary itself. It's the final, undeniable source of truth that has the actual answer you were looking for all along. Okay, so we've got the IP address. We know where we're going. But hold on, before we start sending any sensitive stuff like a password or your credit card number, the browser and the server need to set up a secure, private channel. And they do this with something that's a lot like a polite, secret greeting. And this is what we call the TCP three-way handshake. It's a really simple but super reliable little conversation. Your browser sends a SYN packet, which is basically just saying, hello, you there. The server gets that and replies with a SYN-ACK, which means, yep, hello back, I hear you loud and clear. Finally, your browser sends an ACK, saying, awesome, connection confirmed, let's start talking. It's only after those three steps that the connection is solid and ready for data. Now, on top of that handshake, we layer on security with something called TLS. And this is where things have gotten really cool. The older version, TLS 1.2, needed this long back-and-forth conversation. We're talking 5 to 7 packets just to get a secure connection going. But the newer standard, TLS 1.3, is a total game changer. It cuts that whole process down to just a few packets, sometimes even 0. So what does that actually mean for you? It means security doesn't slow things down anymore. The website feels faster, snappier, and it's even more secure. Win-win. So we have an address, we have a secure connection, but what if the server is halfway across the world in New York and you're in New Delhi? That physical distance, what we call latency, can really slow things down. And this is where content delivery networks, or CDNs, make their grand entrance. Think of them as the internet's express lane, built to solve the problem of distance. A CDN, at its heart, is a global network of local warehouses for website content. So instead of having to fetch all the images and files from one single, faraway server, the CDN lets you grab a copy from a server that's practically right around the corner from you. This one simple idea makes a massive difference, slashing load times and making everything feel incredibly fast. And this chart, yeah, it really spells it out, doesn't it? With old school hosting, everything comes from one spot. That means high latency for anyone far away, and if you get a sudden traffic spike, good luck. But modern CDNs flip that script completely. They deliver content from local edge nodes, which means low latency for everyone, automatic scaling, and this is huge, a really powerful layer of security that a single server just can't compete with. So how do the big players actually stack up? Not all CDNs are built the same. Their performance really comes down to their core network architecture. So let's take a look at three of the giants: AWS CloudFront, Cloudflare, and Akamai. Right away, you can see three totally different philosophies at play here. CloudFront uses a tiered system, lots of local edge locations that feed into bigger regional caches. It's perfect if you're already living in the AWS world. Cloudflare, on the other hand, uses a flat anycast network, where basically any data center can handle any request and they just zip you to the closest one. But Akamai, well, Akamai plays a completely different game. And this number, wow, it really tells you everything you need to know about Akamai's strategy. Over 4,100 edge nodes. Their secret sauce is that they put their servers inside the networks of the internet service providers themselves. For a lot of users, that means the content is coming from inside their own local network. The number of hops it takes to get to you is almost zero. You just can't get any closer than that. Look, a fast network is awesome, but modern websites and apps need more than just speed. They need to be smart. And the next big frontier for CDNs is programmability, giving developers the power to run custom code right at the edge, as close to the user as possible, so you don't even have to go back to the original server. And the really big difference here is how they let developers customize things. CloudFront has Lambda at edge, which is really powerful, but it kind of locks you into the AWS ecosystem. Akamai uses a declarative rule engine. Think of it like a big set of if this, then that statements, which is super stable for big companies. But Cloudflare has really pushed things forward with their Workers platform. They're these lightweight, incredibly fast compute instances that run on the same engine that powers the Chrome web browser. And that brings us to this number, less than 5 milliseconds. That's the typical cold start time for a Cloudflare worker to spin up. What that means is you can run really complex custom logic like A/B testing or custom authentication or personalizing a page right at the edge with pretty much zero performance hit. For developers, that is an absolute superpower. So after all of that, which one's the best? Well, like with pretty much everything in tech, the real answer is, it depends. It's not about finding the one best CDN. It's about finding the one that is the absolute right fit for what you need right now. For instance, if your entire world already runs on Amazon Web Services, then CloudFront is kind of a no-brainer. Its integration with things like S3 and EC2 is a massive, massive plus. But if you're not in that world, it can feel a little complicated, and honestly, the pricing can be tricky to predict. Now, on the pro side, Cloudflare is amazing for its ease of use, its fantastic developer tools like Workers, and its predictable pricing. It's great for just getting up and running super fast. The main trade-off, or con, is that some of their best security tools are only available on their pricier enterprise plans. And then you've got Akamai. If you are a huge global company, I'm talking big-time media or e-commerce, and performance is absolutely non-negotiable, Akamai's network is just in a league of its own. The catch is, it's really built for big enterprise contracts. It's not really a self-service, developer-friendly kind of platform. And that really brings us home to the most important takeaway from all of this. This journey of a web request is a total marvel of engineering, right? It's built on all these amazing layers of optimization. And when you're choosing a partner to help you manage that journey, the goal isn't to pick the one with the most bells and whistles or the biggest network on a spec sheet. It's about really understanding your own needs, your team, your budget, your users, and finding the platform that fits you best. So the only question left is, what's the right fit for you?